For the first time, something was left behind. Not debris, not ruins, but evidence that should not exist. This is the moment the mystery stops being theoretical. Up until now, the Vanishings had one defining feature: nothing remained. No radiation, no fragments, no gravitational scars. Stars disappeared as if they had never existed. But this time, the universe made a mistake. It left something behind. And once the archive saw it, there was no going back. The alert came from a deep survey array monitoring a silent coordinate near the outer galactic rim. At first, it looked familiar: another vanished system. Another blank entry in the archive. But when analysts zoomed in, something was wrong. The star was gone, the planets were gone, yet their orbits remained. Perfectly curved paths, circling nothing. In physics, this should be impossible. Without mass, gravity collapses. Without gravity, orbits dissolve. But here, the geometry held, as if the system had been carefully removed without disturbing the frame it once occupied. The archive classified it immediately. Event type 0, residual structure detected. This had never happened before. You can destroy a system, but you can't erase it and keep the shape. To understand the anomaly, the archive reconstructed the event. They simulated every known cosmic catastrophe: supernova, black hole collapse, gamma ray burst, even artificial stellar harvesting. Every single model ended the same way: chaos. Debris fields, energy spikes, gravitational turbulence. But the real system showed none of these. Energy levels were frozen. Spacetime curvature was intact. Quantum noise was absent. Not reduced, absent. As if reality itself had been neatly unplugged. This wasn't destruction, it was precision. Then came the most unsettling detail: time. Inside the residual structure, atomic decay rates were inconsistent. Some particles behaved as if no time had passed at all. Others suggested thousands of years had elapsed. The system wasn't just empty, it was out of sync. A moment torn out of the timeline and left behind. Archive physicists struggled to describe it. Finally, one of them used a word no one wanted to hear: extraction. Not explosion, not collapse, removal. If something can extract an entire star system, it understands reality better than we do. So, why take a system? Why not just destroy it? The archive began comparing data: silent coordinates, vanished stars, and now, this one residual structure. A pattern emerged: systems with stable planetary arrangements were disappearing more often. Systems with complexity, with balance, with potential. This wasn't random selection, it was curation. Someone or something wasn't erasing chaos, it was collecting order. The universe wasn't being cleaned, it was being archived. An analyst asked the question no one wanted on record: how similar was that system to ours? The answer came back quietly: too similar. Orbital ratios, energy stability, habitable zone positioning. Not identical, but close enough to matter. The room fell silent. Because the implication was unavoidable: if systems are being chosen, then criteria exist, and if criteria exist, then observers exist. We are no longer watching the pattern. The pattern may be watching us. Before closing the case, the archive ran one final scan, a deep layer analysis of the empty system. And buried within the silence, they found it. A faint structure, not matter, not energy. A mathematical residue, a signature, too consistent to be natural. The first sign that the Vanishings leave behind a fingerprint: someone had been here. The archive reclassified the phenomenon, not as a disaster, not as a mystery, but as an operation, and operations escalate. This was not an ending, it was a test.